Welcome to the online lectures for software engineering. In today's class, we'll be discussing business process engineering. Now, business process engineering, it is also called as BPE. Now, the goal of the BPE is to define architectures that will enable business to use information effectively. That is, a business organization, it is going to have loads and loads of information. That is, a lot of data is going to be stored within an organization. So this business process engineering is creating architectures so that this data can be used efficiently by different organizations, so that you can efficiently use data by different organizations. Now this organization means it is a business. So the job of BPE is to define multiple architectures so that data can be used efficiently. Now BPE is an approach for creating an overall plan. Now in here we are also creating a plan. Now this plan is going to tell you how you're going to implement this architectures on the data. So there are two things. One is transforming it and making a plan how you're going to implement this architecture. Now, three different architectures must be analyzed and designed within the context of business objective and goal. That is, whenever you're going for business process engineering, there are three architectures that you need to define: the data architecture, the application architecture, and the technology infrastructure. Now coming on to the first part, that is the data architecture. Now within the data architecture, as the name says, we are going to architecture the data. This data architecture is going to provide you a framework. Framework means like a structure. It is going to provide you the structure for the information needs of a business. That is what the information is required by a particular business, that it is going to structure that type of data. What type of information is needed for this entire organization, or this whenever this organization is doing some specific task. So for that specific task, what type of data is identified, you're going to identify and you're going to make that data structures. The individual building blocks of architecture, that is in here, whenever you're designing the data architecture, the building blocks of architecture are called as data objects. Now what are these data objects? We'll take an example for data object. A data object, if suppose there's an information engineer. Now this BP is completely focusing on information or data. So you're going to have an information engineer. So this information engineer is going to define a data object. Now this data object, taking an example, it can be a customer or it can be a product. So these are the two examples for data object. Now why are these data objects used? These data objects are used by the business. That is, whenever you're designing a particular software, the customer, that software is called as the product, and this product is consumed by the customer. Now this data object is going to have different attributes, and these attributes can be defined as quality, characteristics, or different descriptors. Now we'll see an example for data object. Now we're defining an object. This object is customer. So we're going to define the attributes. As you've seen, that data object has got attributes. So these attributes can be name of the customer, the company name where he is employed, what is his job classification, and purchase authority. How or what are the authorities for purchasing this particular software by the customer. Then you can have the business address and contact information. This basically is your business cards, where you're going to have the company's address and you're going to have some contact details. Then you can have the product interest Now this can be for one particular product or for multiple products. That is why the S. Past purchases means how many products or softwares were purchased by the customer. Date of last contact. And the status of contact. Now status of contact means whether he's here for purchasing the software. Now if he's purchased the particular software, whether the software is being developed or not, all of the things are going to be identified. So this is the entire description of what a data object is going to be. This is the data object. Within the data object, you're going to have multiple attributes that this customer is going to have. So in here, these data objects, these are used. They can be, like as I said, there are different attributes. Now let me give you another example. Now in here you're going to define multiple data objects. Now the first example is the customer. If we take the second data object as product, so when you define these different products, now this product is also going to have the different attributes for it. Now when you have the different attributes for this particular product, after you've defined the different attributes for the different customers, or sorry, for different objects, what you're going to do is you're going to identify what is the relationship between the two products. What is the relationship? Relationship means how they are connected. That is going to be identified. Now if we connect the customer with the product, what is the relationship? The customer is going to purchase the product. So the relationship is purchases. The customer is purchasing the product. These two objects are connected by the relationship. There are multiple relationships. So one relationship is the purchasing relationship between these two different data objects. Now, the next type of architecture that is used by BPE is called as the application architecture. Now, this application architecture, it comprises of those elements of the system that are going to transform the objects within the data architecture for some business process. Now, we have studied the different, we know what are the different data objects. It can be a product, it can be a customer, it can be anything. So in here, this transformation job, it will be this transformation job, it is going to be done by a software. The software is going to perform the transformation. Now, in broad terms, if we say what the software application architecture is. Now, this application architecture, it can be the different roles of people, or the role of a business procedure. Now these roles are identified when they are not automated. That is, now the specific role of the people, the specific role of a people, if suppose a particular person is a manufacturer. Now this manufacturer is not automated. He's a particular person that is doing a specific job. So within this application architecture, you're going to define the different roles of the people, whether he's a manufacturer, whether he's a user, whether he's a customer. Each of the things are defined. Now these roles of people are identified for things that are not automated. That is the things where the machine is not doing the job. The next type of architecture is the technology architecture infrastructure. Now this technology infrastructure, it is a foundation for the previous two architectures that we have studied, that is the data architecture and the application architecture. If you do not have this technology, then there is no use for building a data and application architecture. So this technology infrastructure, it is the foundation for data and application architecture. Now this infrastructure, what is this going to have? This is going to have hardware and software that is going to support the application and data. That is the specific tools that you're using or the specific programming language that you're using. This is going to be there within the technology infrastructure. Now, upon this hardware and software, this data and application architectures are going to be supported. Now, let's see a few examples in here for technology infrastructure. Now, examples can include computers, operating system, networks, telecommunication links, how you're going to store the data, the storage technologies, the database, data warehouse, this is going to be identified, and the architecture. Now the example for this architecture, it is client server architecture. This client server architecture is defined so that you can implement technologies. So this is the job of the technology infrastructure. We've seen 3 different types of architecture that are designed within the BPE. What is the job of BPE? So that you can make an architecture for data so that it becomes very efficient for the organization to use that information. Now this is the diagram of business process engineering hierarchy, that is the BPE hierarchy. Now within this business process, this diagram we have already seen within the previous class also. The first view is called as the worldview. Now this worldview, it is achieved by the information strategy planning, that is this is ISP. The worldview is achieved by the information strategy planning. Now within this information strategy planning, this ISP, it is going to view this entire business as one enterprise. That is why you're giving within the worldview, you're giving the name as one entity, that is one enterprise. You're going to see it as one whole. It is going to view this entire business as one entity, and the next job that it is going to do is it is going to isolate all the domains. Now what are domains from the previous class? The domains are the areas of interest. So you're going to isolate the domains of business. Now what are the different domains of business? The different domains of business, it can be the engineering field, marketing field, finance, manufacturing. These are the different fields. So you're going to identify those different fields and you're going to isolate each of the field. Now in here, the ones that are important within this business, you're going to consider those particular fields only. Now the next job that this ISP is going to do is, this ISP is going to identify the different data objects. It is going to identify the different data objects that are visible from the enterprise point of view. That is, from the world view, what are visible, you're going to identify those different data objects. Now when you define data objects, we can identify the relationship between these data objects that will be identified at the enterprise level. And when you know the data objects and relationships, what can you get to know? You are going to know what is the flow of data that is going to take place. How data is flowing from one entity to another, or within the different business domains, that will be identified within the first phase. That is the world view. The next view is the domain view. Now within this domain view, this domain view is going to add, it is going to address the business area analysis. This is called as your BAA. The domain view addresses the BAA. Now what is the job of this BAA? This BAA is going to identify, BAA will identify the different functions the different data requirements. That is, you're going to have functional and data requirements. Two things will be identified. The first one is functional requirements and second one data requirements. These are identified by the BAA. Now this business functions that are identified for functional and data requirements, these are done upon the business areas that were identified by the ISP. That is, this is done for this different business process areas that were identified within the worldview. Now the other job that this BA is going to perform is the same thing. It is going to identify the different data objects, their relationships, and the data flow. These are identified from the domain view point of view. Now one more thing that this BAA is going to do is, now as within the worldview has isolated the different domains of business. Now this BAA is going to isolate the different opportunities within the information system. Let me write it down. The different opportunities in information systems. These are isolated. Apart from identifying the different data and functions, it is going to isolate different opportunities. Like within engineering, marketing, and finance, these are the opportunities of interest. In here, within the information system, if any more opportunities are there, that are going to be identified by identifying the different set of requirements. Now, once all the information system are isolated for further development, that is, these opportunities, these are used for further development. Further development means whenever you can go for detailed description for this particular task. Now, once all of this is identified, this business process engineering is going to identify the business system design. Now, this business system design, in terms of software engineering, it is called as the analysis. So within this BSD, you're going to identify the basic requirements, of one specific information system that you have identified. Based upon that, you're going to create models. You're going to model the different requirements, you're going to model these requirements. Then all of these requirements are going to be translated into the architecture that you have studied. That is the data architecture, the application architecture, and the technology infrastructure. This is going to be transformed into 3 different architectures. Now, when this is transformed into 3 different architectures, the final business process engineering step is going to be the construction and integration phase. Now, within this construction and integration phase, you're going to focus on implementation, how you're going to implement each and every function within the software. You're going to focus upon the implementation details. What are the different architectures that you're going to use, or the complete infrastructure, that is the entire structure, will be identified in here. Now this all is done by making an appropriate database. Now this database is going to have all the different data structures. These data structures that will be used for building an application, that is a software that is being designed for building the application using software components. So this is the entire business process engineering hierarchy. Now a quick recap. Within the first phase, what is going to happen? This worldview is achieved by information strategy planning. This information strategy planning, it is going to view the entire organization as one single entity. That is why the name is given as enterprise. When it identifies the entire entity as one entity, then it is going to isolate the different domains of business. The different domains are engineering, marketing, finance, manufacturing. These are the different phases. Now these different domains, you're going to identify the domains that are important. Those important domains will be identified. After identifying the different domains, it is going to do the second job, that is, it is going to identify the different data objects. It is going to identify the different data objects from the worldview it is going to identify. Now when you identify the different data objects, you're going to establish a relationship. Like within the previous example we have seen, when you're connecting a relationship between the customer and product will be purchases. That relationship will be identified. When you know the different relationships, you will identify how the flow of data is going to take place within the business domain. The first step is completed. This is going to be the entire first step till here. Within the second phase, this domain view is going to address the BAA, that is the business area analysis. The job of business area analysis is it is going to identify the different functional and data requirements. Now these functional and data requirements, these are identified for the domains that were identified by the ISP. What domains you identified, based on that you're going to give a more level of detail. As you go down the hierarchy, you're going to add details to each and every step. So you're going to identify functions and data requirements for these set of domains. Now when you identify these different functions, you're going to create data objects and the relationships and how data is going to flow from one system to another. Now the outcome of BA, that is, once you identify and isolate all these functions, you're going to identify the different opportunities in the information system. Now the different opportunities are going to be isolated. That is, further what options you're going to develop, like sub-programs. You're going to identify what more features need to be added to a specific function. That is going to be isolated. Now within this information system, that is the element view. This BPE is going to implement the element view by BSD, that is the business system design. Now if suppose we consider within the software engineering term, it is called as the analysis part. Within this analysis part, you're going to identify what are the basic requirements. Now when you identify the basic requirements for the information system, for this information system, you're going to start modeling the requirements. That is, when you know the requirement, you can implement that in an architecture. You're going to implement these requirements into three different architectures, that is the data architecture, application architecture, and the technology infrastructure. When this part is done, you go to the last fourth view in the hierarchy, that is the construction and integration. That is the detail. You're going to have everything in detail in here. Now this construction and integration, it focuses upon the complete implementation of the architecture and the infrastructure. Now in here, the architecture and infrastructure, these both are implemented by identifying the databases. That is, you're going to identify the entire database, what is going to be used, the different type of data that is going to be stored, and the different data structures are going to be identified. Now by taking this database and data architectures, you're going to identify how you're going to build an entire application by making use of different software components. This is identified. Now this BPE, it was asked within the previous examination, so this answer is important. Now moving on to the next part. The next one is product engineering. Within product engineering, the goal of product engineering is to translate The goal of product engineering is to translate the customer desires for a set of defined capabilities into a working product. That is what the customer wants, that is your customer desire, that what he wants within the software. Now his requirements are going to be converted into a working product, that is a software or application. Now this product engineering, like the business process engineering, the previous model that we have studied, product engineering like the BPE, it needs to derive different architectures and infrastructures. Within BPE, we have studied three different architectures: the data architecture, the application architecture, and technology infrastructure. Whereas product engineering, it also needs to make a few architectures and infrastructures. Now this architecture that the product engineering is going to make, it is going to have four distinct systems components. These components are going to be software, hardware, data, and people. Now this is the diagrammatic representation for the product engineering hierarchy. Now within the product engineering hierarchy, this worldview, it is achieved by requirement engineering. Now in here we can identify by the term requirement engineering means you are going to gather all the requirements for developing a particular software. Now each and every stakeholder, that is people that are going to be benefited by this software, they are going to have different requirements. So you're going to identify different stakeholders and you're going to gather requirements from all of these people. Now this product engineering, it is going to view the worldview as one complete product. Now these requirements, now what are these requirements? We'll write down the different requirements. It can be information on the different control needs, how you're going to control the software, what are going to be the product functions, that is the different features, and what is going to be the behavior, that is what is going to be how you're going to operate on the system, and what is the environment in which you're going to operate the system, that is going to be the behavior of. Now this is going to be behavior for the entire product. Apart from this, you're going to also identify what is going to be the overall performance for the software, how is going to be the design, and what are going to be the different external and internal interfaces for the particular software. Once you get to know all of these requirements, when you know all these requirements, the job of this requirement engineering is to allocate different functions and behavior. When this entire thing is known, this requirement engineering, it is going to allocate functions and behavior to the four components that we studied earlier, that was hardware, software, the people, and the database. Database or data. It is going to assign functions for each of the different components. The next part is the component engineering, that is the domain view. Now this domain view within product engineering is called as the component view. That is, in here you're going to focus on the development of each and every component. Once you've allocated all the different functions and behavior to all the components, now at this time the component engineering is going to start. At the second step, component engineering starts. Now in the system component engineering, it has a set of activities that is going to focus on each and every component differently. That is, once a particular software is not going to be made up of one component, it is going to be made up of different components. So in here you're going to work on all the components concurrently. Concurrent work upon different components is going to be performed, like software engineering, the different hardware engineering, human engineering, database engineering. All of this is going to be done. Let's write it down in here. Software engineering, HE will be hardware engineering, then human engineering and database engineering. That is, whenever you're designing the software, you're going to focus upon the software, hardware, human interaction. That is how the software, how the user is going to interact with the system, and what type of data will be used. That is going to be identified. Then the next view is the element view. Now within the element view, for the product engineering, the engineering disciplines are applied for each and every component. That is, what are the different data, what are the functions, what are the behaviors. This all are identified. These are your engineering disciplines. All of them are identified in here. This is also called as your analysis and design modeling. That is the element view. Then later, each and every element in here, each and every element view, that is the data, function and behavior, you're going to start construction and integration of each and every component. Now all of this job, it is done for all the different components. For hardware also this will be done, for people, for databases, for each and every component this is going to be identified, and you're going to have in detail how you're going to implement each and every feature that is going to be identified within the construction and integration. Now within the construction and integration, you're going to do the coding part, code generation. You're going to do the testing, and supporting steps are going to be done. Supporting step means like adding manuals, installation guides. This all is going to be identified within the construction and integration. So in here you can see, whenever you're traversing from top to bottom, that is from each level of hierarchy, you're adding levels of detail at each step. That is called as your data abstraction. You're adding detail at each and every step whenever you're designing the software. The next topic that we'll be studying is system modeling. Now, what is system modeling? Now, within the previous topics, we have seen that there are different levels of abstraction. Now, these different levels of abstraction are called as your world view, the domain view, or the element view. These are the different views within the system. As hierarchy is refined, you're going to identify each and every detail for the components that you're building. So this system model is going to transform all of this into models. Models are going to be developed for each and every view. That is called as system modeling. Now within system modeling, the first model that we'll be studying is called as the Harlan-Pfi modeling. Now this Harlan-Pfi modeling, it is extension of the concept of every computer-based system. What does every computer system do? It is going to take input and it is going to process it into output. So within this Harlan-Pfi modeling, you're going to add an extension to it. You're going to add the extension to it. That extension is going to be the user interface processing and the maintenance and self-test processing. You're going to add these two things within the conventional computer-based systems. Now, let's see the representation of how this Harlan-Pfi modeling is going to look like. The system engineer is going to allocate all the system elements to each of these 5 processing areas. That is the user input, system functions, control, output, maintenance, and self-test. You're going to have this basic one is input process, the CPU, then output process. 2 additional things that you are adding in here are the user interface processing and maintenance and self-test. That is, you're going to have altogether 5 components are going to be there within the Harlan-Pfi modeling. Now within this, let's see an example also. Now, whenever you're designing a Harlan-Pfi model, you're going to draw system context diagrams, also called as SCD. Now, the system context diagrams, they are going to define the different external procedures, the external producers of information. Now, what are going to be the external producers of information? The external producers of information, these ones are used by the system. Then you're going to have the external consumers of information. Now this external consumers of information, these ones are the ones that are created by the system. So this system context diagram, it defines two things: the external procedures and the external consumers. And it is also going to identify all the different entities. Now how this all entities are going to communicate through different interfaces, and how they are going to perform the maintenance and self-test, that is going to be identified. So this is what an SCD is. Now this SCD, it establishes, like in other words we can say, it establishes an information boundary between the system that is being implemented, that is the system that you're working on, and the environment in which you're going to operate this system. That is the basic definition for the system context diagram. Now all major subsystems are defined in a system flow diagram. Now this SFD is called as a system flow diagram, which is derived from the system context diagram. That is a more detailed representation that is going to show you how information is flowing. That diagram is called as the system flow diagram. The information flows across the different regions, but now these regions are the 5 different components, or we can say the 5 different areas. That is like the input, output, the processing, the user interface, and the maintenance and self-test. These are the different regions. So information flows across the regions of the system context diagram. This is used to guide the system engineer of how he's going to design the system flow diagram. Now let's take an example for, this was the system context diagram for CLSS. Now CLSS stands for conveyor line sorting system. Now within this conveyor line sorting system, you have the input processing, you've got the output processing. Now the 2 additional features that are added, that is the user interface processing and maintenance and self-test. These are the 2 things that are added. Now in here, each box in here represents an external entity. Now this external entity, it can be the producer or it can be the consumer. We've seen the producers and consumers, like the system context diagram that they use for producing and consuming of information. These are your boxes. Whereas the arrows, these arrows represent information as it moves. That is, it is going to tell you information flow from the external environment into the conveyor line sorting system. Now the conveyor line sorting system, this is a system where when you visit a shopping mall, you go and stand at the counter. Now these counters, these are automated counters. In here, within the example that we're considering, you got automated counters in here. Now this conveyor line system, it is going to have a user interface processing where the user is going to give the input. Then you've got input processing and output processing based upon the commands that, or the different entities that are passed that is going to be recorded and the output is going to be displayed. Now within the user interface processing, first the user is going to stand in a line, and when his turn comes, he is going to access the conveyor line sorting system. That is sorting station operator. You are going to send a request to the conveyor line sorting system, and any queries, if there are any queries to be asked by the operator, this job is done at the user interface processing level. Now when your turn comes, what you're going to do is, for each and every product that you've purchased, each and every product is going to have the barcode. So you're going to scan your products across the barcode reader. You're going to scan your products across the barcode reader, and then your product is going to pass through the conveyor line. This conveyor line is the moving belt on which you place your elements, and your items, they move forward. As your items move forward, you're going to scan each of the product's barcode, and this is your input that is given to the CLSS. Now this CLSS is going to issue the different shunt commands for sorting mechanism. Now in here, if suppose you've purchased 5 packs of chips. Now you're not scanning all 5 packs of chips at one time. You might scan first chip packet as being scanned, then after that a few items, then the 2, then the other 2 are scanned. So in here, this within the sorting mechanism, within the bill that is being generated, within this bill, you're going to have all this 5 chip packets mentioned all together. This job is done by this shunt commands. So this shunt command is going to have all of this. That is, the output produced is going to be, your bill is going to have all of this within a sorted order. Then the next one is formatted reporting data. This data is issued on the mainframe. Now within this mainframe, as you see, there is a display that is placed at the conveyor line sorting system that is going to display the price of the products as you scan. That is, the price is added and you get to see here the total that is being displayed at the mainframe. Now in here we have seen the first part, that is the input and output processing. Now we come on to the maintenance and self-test. Now within the maintenance and self-test, now if suppose there are any errors or bugs within the system, that job will be done by maintenance and self-test part. That is, from the CLSS, you are going to collect some diagnostic data and you're going to check whether the software is working well or not. If any bugs are there, those bugs are going to be fixed in here. This is the system context diagram for CLSS. That is, you've got the input processing, output processing, user interface processing, and maintenance and self-test. The next part of modeling and system modeling is system modeling using UML. Now UML stands for Unified Modeling Language. Now this Unified Modeling Language, within the Unified Modeling Language, you've got different types of diagrams. Now you've got 2 types of diagrams. You've got structural diagrams and you've got behavioral diagrams. Now within the structural diagram, you're going to have class diagram, component diagram, the deployment diagram, and object diagram. Whereas within the behavioral diagram, you're going to have use case diagram, activity diagram, sequence diagram, communication diagram, and the state machine diagram. Now combining all this, you're going to have total, the diagram that we're going to study are 9 diagrams. Within a syllabus, they're going to be total 9 diagrams. So the diagrams are divided into structural and behavioral. Those are called as your UML diagrams. Now this UML, it provides a wide array of diagrams. We have discussed the different 2 types of diagrams. These can be used for analysis and for the designing part. Analysis means you're going to see whether all requirements are matching the ones that are stated by the customer. With the design, you're going to identify the different interfaces, the different components within the system. Now for CLSS, within the Harlan Pfi modeling, we have considered the conveyor line sorting system. Now 4 system elements are modeled. That is, you're going to model the hardware, the software, operator and database. Now within the hardware, this hardware, it is going to enable the conveyor line sorting system. The software is going to implement the database, that is the stored prices are going to be stored. Database, it's going to access the database and it is going to provide the sorting. The shunt commands that I told you, that if you buy 5 packets of chip and you scan them differently, all 5 packets are going to be bundled together and showing it will show us one within the receipt. The operator, now this operator is responsible for submitting various requests to the system. Request to the system will be given by the operator. Then you're going to have database. Now within the database, what you're going to have? You're going to have the relevant barcode of each data item and some additional information will be stored. So this is your UML, the introduction to UML diagrams. The next one is, now for the same CLSS system, that is the diagram here that we have studied. For the same diagram, we are going to draw this UML diagrams. So the first diagram that we're going to design in here is called as the deployment diagram. Now what is a deployment diagram? Now as the name suggests, deployment. Now what does deployment mean? Deployment diagram, this type of diagram, it is called as your structural diagram. Deployment diagram is one of your structural diagram. It shows the structure of the system. Now these deployment diagrams are used so that you can describe the different hardware components. Now this hardware components are going to be the components where your software is going to reside. That is the deployment diagram. So for the CLL processor, what are the different components, hardware components will be identified. Within the CLS processor, you're going to have the sorting subsystem that is going to sort all the items. Then you're going to have the operator display, that is your mainframe, where you're going to have all the total amount where it was going to be displayed. Then the next one is sensor data acquisition subsystem. That is within the sorting subsystem, you're going to scan your barcode. So when you're scanning your barcode, this is going to be scanned across the sensor. So sensor data acquisition subsystem. Within the sorting subsystem, you've got this barcode scanner. Then the next one is called as your shunt controller. Now the example of shunt controller that I've given you, that it is going to sort all the items within this sorting subsystem. This shunt controller is one another component that is going to sort and arrange items in an order. That is a chips packets example. Then within the sensor data, you're going to have the conveyor pulse stack. Now what is this stack? Is your tachometer. That is, you've got this revolving rotor that is going to, the conveyor belt that is going to move your items forward. This revolving belt is called as your conveyor tach pulse. That is your, within the sensor, you're going to have this conveyor pulse stack and the barcode reader. Then within shunt controller, you're going to have this shunt actuator. Now shunt actuator is called as your shunt operator. So this is the deployment diagram. Within this deployment diagram, you're going to have the different hardware where your software is going to reside. This is identified within the deployment diagram. If you go for the next diagram is called as the class diagram. Now this class diagram is a structural diagram, and class diagram shows the structure of the system that you're developing. Now within this class diagram, there are 3 boxes. That entire one box is going to be split into 3 different boxes. The first box, this is called as your class name. Then the second box is called as your attributes, and the third box is called as your operations. So within the first box, that is a class name, you're going to have box as your class name. Now within that, the different attributes will be that the particular you're going to have this barcode forward speed, that is how the conveyor belt is going to move. The conveyor location, that is when the conveyor belt is moving, what is the location. Then the height of the items, width, depth, weight, and contents. Each of these are the different attributes for the box. Then within the operations means what are the different tasks that are going to be performed. Reading barcode, this is the task that needs to be performed. Update the speed, reading the speed, update the location, reading the location, get dimensions, get weight, check all the contents. So these are the different operations that are done for the CLSS. Now if we take a simple example for a particular person, if we draw a class for person, we'll have the first compartment, second compartment, third compartment. This is the example that I'm taking. The class name is person. Now what are the different attributes the person is going to have? He's going to have his name, he might have his address, he might have some ID. So these are the different operations, different attributes for the person. Whereas the operations the person is going to perform is, he's going to eat, is going to play, walk, these are different operations. So the first one is your class name, second is attributes, third is your operations, attributes and operations. One simple example for class diagram. Whereas the next one is the use case diagram. Now this use case diagram, it is used so that you can identify what is the behavior of the system. The use case diagram, it shows the behavior of the system. Use case diagram, it shows the behavior of the system. Now this person in here, the stick man, is called as your actor. The stick man here is called as the actor. These round boxes in here are called as use case. This rectangle in here is called as your system boundary. And the lines that are connecting this use case and the actor, these are called as your relationships. That is within the previous topic we have identified the relationship between the object and purchases. Like we had customer and we had product, two data objects, and those were connected by relationship, that is purchases. That is a similar example for purchase. Now within the CLSS hardware system, you're going to have the CLSS hardware. Within the CLSS, you're going to identify the stickman, that is the actor. Now this actor is going to interact with this system. This class operator, he is going to interact with this system. So the CLSS operator is your actor. He is going to, the different tasks that he's going to perform is, he's going to request for the barcode, then request shunt control status, that is how your operations are, how your items are going to be sorted. Then the processing report, that is the total amount. Then update the product database, that is in here if any items you need to add or remove, that is going to be updated and it is going to reflect within your total balance. Then run system diagnostic, this is for the maintenance of the software. So these are the three diagrams that is the two ways for designing a system model. The first one is Harlan Pfi modeling, and the next one is by using the Harlan Pfi modeling, and the next one is by using UML representations. Any of the 9 diagrams can be used. Now these different 9 diagrams we'll be discussing in detail within the lab sessions. This is the end for today's class.